Okay, once more. I was hoping you'd have this locked in just a little better, but in talking about it, y'all did pretty well. You've got all the pieces except for one that we haven't talked about. And we talked about it early in the semester. Should have locked it in then, but in the real world that never happens. Okay, so you got F equals negative kx, right? One thing is, it's a path-independent force that's conservative, okay? Work done by a conservative force. From you need to fill in the details. We just talked about them. You know how to fill them in. Go to the definitions, work out the details, so you totally understand why this is true. Okay? Here. Mx double prime equals negative kx because force is mass times acceleration, right? And x double prime is acceleration. Newton's second law, okay? Now you can't tell me why this is equivalent. You can't tell me why, because you don't have the theoretical background of early differential equations, okay? A couple of you will have it within a couple of months, because it's fairly simple, but we're not going to talk about that. Accept it, and then sometime in January or so, ask people who are taking differential equations, okay? Anyhow, this is what we have. You need to know how to verify this. How are you going to verify that at least this is a solution? Verify if this is a solution with two arbitrary constants. Now the easy part is it has two arbitrary constants, and you told me what those were, phi and a, right? And I guess the other thing we should say is the thing that people keep never remembering. This is it, okay? How do you verify this now? How do you verify that this is a solution?
Well, if t equals 0,
Do what?
if you let t equals 0, you can find phi.
Yeah, that's good if you're trying to apply it to a situation where you have the information to use that. But that doesn't prove that this is a solution to this equation. How do you prove that something is a solution to an equation? If y'all can't answer that in a microsecond, you're giving me insight into why it's like pulling teeth to get my pre-calculus students to check their work. You plug it back into the equation and see if it gives you an identity, right?
Oh, yeah.
Now, why in the world, how in the world have y'all gotten really pretty good educations up to this point and not been able to tell me instantly that very fundamental thing that you do with every problem you do, you check it, although you don't. Why don't you? Because of SOL. What's the point of checking your solution after you've circled it, right? Okay. Get over it. Check your blamed work. If you're not checking your work, you'd never get feedback as to whether it's right or not, except that somebody tells you this is right or this is wrong. If you check it yourself, then you have an internal process that accelerates your learning by a factor of at least 2. You will learn faster, you'll learn better, and you'll make better grades. Okay? Check your work. If you don't have time to check every problem, well, if you've already checked one of this type and you think you've done the same thing and you're in a hurry, maybe you can kind of put that off like forever, because if you don't do it right now, you never will. Okay? Check it. Plug this into here and see that it's a solution. Okay? I don't know why. I do know why. I don't know why. It's very difficult to tell people to do that and have them actually understand what I'm talking about. Something terribly wrong in our educational system, okay? That people don't automatically think to check their work, even if they don't always have time. If you don't check your work, you need to be pretty darn uncomfortable about it. Unless you're in something, in a situation where you have a high level of comfort, okay? And hopefully you get there with all situations. Okay, anyhow, end of that little sub-lecture. But this is what you know about simple harmonic motion. You don't need to know anything else. Everything else is just simple algebra. Well, maybe a little calculus, okay? And maybe it's not that simple, but it's high school level. Except the calculus, which is early college level, okay?